So, when you say you were right, tell me, right? Because I'm just trying to see, I'm pushing you to your limit. Let's see if you're going to take a stand and commit to what you think you know, or if you're just going to let someone talk you out of it. What do you think the growth factor is as a decimal? Fisa told us. Did she not? So the growth factor is 0.015. Then we've got write an equation to represent the total number of students enrolled a year from now. Do we want X and Y or N and T? X and Y. So then we have to write what X is and what Y is. So first let's write that X is, what's X? What'd you say, Fiza? Oh, sorry. Time. X is time in years, because the question gave us years as the unit. And what's Y? Students. Thank you. Number of students. Oopsies. There we go. So, if we are going to let, right, so this is just sort of rough. The proper way of writing it is let Y represent the number of students, and let X represent time in years. Okay? So now we have to write our equation. So we've got Y equals, what did we put before for question 1? What did we put before we even did the exponential piece? The number of students we, right, what we start with. What we start with goes in front of the bracket. So here we've got this bracket, and then we know we are growing at a rate of 0. Right. And what's up here? Which is? Well, it's 10 at a specific point, but what is it? What if we want to find out when it's 9 years or 8 years? So this will be for an X, and then we'll plug different things in. So what's missing from my equation? The 1. Where does the 1 go? Right? Because we have to remember that this is the growth, but this is going to represent the original. We don't want to know just what the growth is. We don't want to know that we just grew 500. We want to know what the total is with the growth, right? So that gives us the total with the growth. And again, we went through this previously, so I'm not going to go through a whole explanation again right now. So you can rewrite this like this if you would like. Okay, so that's B. Now let's take a look at C. Now we have the equation, as Jada said. They just want us to plug this in. So calculate the number of students. We're looking for X or Y? We're looking for Y because Y is the number of students. Why is it? Because we said so. And the number we're plugging into here is 8. Is this a calculator in between your ears or a calculator in your hand question? Calculator in your hand. Take out your calculators and follow the rules of BEDMAS, like I've said before. Don't forget you're doing the exponents before you do the multiplying. Order's important. So what I'd like you to do is first tell me it with a decimal. Fiza, what do you have? 1,351.79. Now, we've talked about this. You guys are smiling. You know you are never going to tell me that 1,351.79 people went anywhere. They don't go to school, they don't go on vacation, they don't go swimming, and they don't fit in a stadium. Right? Jacob, does this make sense? How come it makes sense, Jacob? You don't know. See, do I look like I was born yesterday? What the heck? You think I don't know your yes when it's yes and yes when it's just try to not pay attention to me yes? Adam, tell me why. Why we won't have 0.79 people. Okay, hold on. How many people got 1,351.79? Okay, a couple people, so check your calculations, Adam. Okay, Bella, what's going on with this 0.79? Why does that not make sense for this question? You can't have half a person? No kidding. Okay, so we know we've talked about this before. There's pure math, there's applied math. We're applying this to real life. So the question was calculate number of students enrolled 8 years from now. So therefore, in 8 years, there will be 1,352 people enrolled. Again, the English department may not be wowed by your sentence. It doesn't have all these amazing adjectives and all that other fancy stuff. But we're not looking for that. We're just looking to clearly communicate what we have to say. Okay? It's like a mathematician does an English class. Okay. So, we've got lots of questions now that we can do. No problem. Let's take a quick look. Starting point, seeing what it's growing to, write the equation, find a specific thing. Just did that. Let's do another one. Starting point, growth rate, write an equation, and stuff like that. Okay, this is similar to what we've done previously with when did it double? Population in millions is this. They give us the equation. What's the growth rate here? 1.4%. Amazing. What's going on here? Here we're decaying. We're decaying. So we know that when we're growing, we have the plus sign, and when we're decaying, we have the minus sign. These are going to be some decaying questions. We've done half-life examples before. You have to refer to them, no problem. We know that if something decreases in value by 15%, if it was worth 100 before, it's down 15% or worth 85% of its previous value, right? We subtract it from 100%. Everything else is not new. We've talked about it. Okay, let's get to work.